Good morning. This is M. Shireesha, working as an assistant professor in CSE department at B.V. Raju Institute of Technology, Narsapur. Today I want to explain a CD subject few topics. It is bottom-up parser. Previously we have discussed about what is bottom-up parser, how we need to apply the parsing technique in bottom-up parser. The main three actions of bottom-up parser that will be implemented by shift reduce parser. Main three actions of shift reduce parsers operations are shift. It is nothing but we need to insert the current input symbol onto the top of the stack. The second one is reduce. If we found any handle at the top of the stack, then we need to reduce the top of the stack with the left hand side non-terminal. Third one is accept. Accept is nothing but if the stack contains only the starting symbol of the grammar, then the input buffer is empty, then we can say that the given input is accepted. And one more action is there, that it is not belongs to above three explained, that is either shift or reduce or accept is not able to perform, then it is not able to shift or reduce the item to the top of the stack, that indicates error action. Totally we are having four different: shift, one, reduce, accept and error. Previous class we have explained the example that is called as a bottom-up parser, that is implemented with one example. Two rules. When we are implementing the shift reduce parser, we are having two rules. That is, the first one is if the incoming operator is having more priority than the stack operator, then we need to perform the shift action. Nothing but whatever the incoming operator is there, that we need to shift on to the top of the stack. Otherwise, if the stack operator is having less priority then the priority of the incoming operator, then we need to perform reduce operation. For example, just we need to take this example, that is the grammar is given as E tends to E plus T RT and T tends to T star F RF, F tends to ID. To perform the shift reduce parsing, the given input string ID plus ID star ID, then we need to take three contents, that is stack and whatever the input that we are storing, that will be indicated inside your input buffer. What type of action we need to perform will be given by action. Okay, first one is stack. By default we don't have any elements in the stack, that is indicated with dollar, and input buffer is nothing but we need to take the input string followed by the end of your input will be indicated with the dollar. Okay, first one we need to compare. First we need to shift the current input onto the stack. Whatever the current input is there, nothing is there in previous thing. First we need to shift the current input onto the stack. The current input symbol is ID. ID will be shifted onto the stack. Whenever we are shifting ID onto the stack, then we can find a handle on top of the stack, that is ID, because we are having a production called as F tends to ID. ID is a handle. Then handle will be reduced by the left hand side non-terminal F. Reduce F tends to ID. Then ID will be popped from the stack and left hand side non-terminal will be pushed onto the stack. The next input symbol is plus. Okay, before inserting the next input symbol, once again we need to see the current top of the stack. Once again we can apply the reduce action because it is also a handle, because we are having a production called as T tends to F. Then once again we need to apply the T tends to F reduce action. Then we are going to get the top of the stack as T. When you observe the top of the stack, once again it is a handle. Then we need to reduce by using a production called as E tends to T. Then it will be reduced, then we need to push E onto the stack. Okay, then next input symbol is plus. Then when you observe the top of the stack, it is not a handle. Whatever the next input symbol that is there, that is plus. Plus will be pushed on to the stack. Then current stack contents are E and plus, but it is not a handle. What you have to do, if you won't find a handle, we need to push the next input symbol onto the stack. Next input symbol is ID, that we need to push onto the stack. ID will be pushed onto the stack. Then stack contents are E plus and ID. When you observe the top of the stack ID, once again it is a handle. We can perform the reduce operation, that is called as reduce F tends to ID, because we found ID as a handle. Whenever you found ID as a handle, we can perform the reduce action. By performing the reduce action, ID will be replaced with F. Once again F is a handle, we need to reduce F with T. then we are going to get it as E plus T. Okay, when you are having E plus T, in this case we need to observe either we need to perform shift operation or reduce operation. Okay, next incoming operator is star, previous operator is plus. When we compare the precedence in between these two operators, star is having higher precedence, then we can perform the shift operation. In place of this star, if we have plus, then left plus and right plus, when we comparing, left plus is having higher precedence. In those cases, we can perform reduce operation. For that purpose, we need to check the precedence of the operators. Okay, what is the current operator and what is the previous operator that is there on the stack. If the current incoming operator is having higher precedence, then we need to push that particular operator onto the stack. Okay, after pushing that one, we are having the stack contains as E plus T star. Then next input symbol is ID, then we need to shift because it is not a handle, then we need to shift it. Whenever we are shifting, then top of the stack is ID. Once again, we need to repeat the previous reduce action, that is F tends to ID. Because ID is a handle, we need to reduce by using the prediction F tends to ID. Then once again, whenever we are observing the top of the stack, we are having T star F. T star F is also a handle. For the production, T tends to T star F. Then T star F will be reduced by the left hand side non-terminal T. Then you are going to get the top of the stack as E plus T. Then we need to reduce E plus T by E because E plus T is a handle. Then we need to reduce that handle by using left hand side non-terminal called as E. Then you are going to get the top of the stack as E. Your input is completed, indicated by $. If your top of the stack contains the starting symbol and your input buffer is empty, indicated by $, then we need to give the action as accept. This is one more example by comparing the precedence of the operators. That is your shift reduce parser. And we are having one more type of bottom-up parser called as operator precedence parser. Operator precedence parser, it is also called as a shift reduce parser because all the bottom-up parsers we need to implement by using shift reduce parser only. Why we need to implement means because in bottom-up parser we are taking the total input string that we are reducing it to the starting symbol of the grammar. When we are performing this one, that is nothing but just we need to take the leaves and reduce it to the starting symbol. All the bottom-up parsers will follow the shift reduce parser only, and the second category of our bottom-up parser is operator precedence parser. Okay, in operator precedence parser, by using operator grammar only, we can construct this particular parser. Previously, we are constructing for context-free grammar. When we are going for the operator precedence parser, first we need to verify whether the grammar is operator grammar or not. If it is operator grammar, then only we can apply that particular grammar to the parser. What is the rule for operator grammar? It is nothing but we are not supposed to have any continuous non-terminals at the right hand side of the production. If we have that type of productions, try to convert that one to remove that particular problem. How can we remove? For example, here we are having one production called as E tends to EAE. When you observe the right hand side production EAE, in this one continuation 3 non-terminals are there. And immediately we are having a production called as A tends to plus or minus or star or division or ID. Means in place of A you can write all these operators. By writing that, you are going to get the grammar like this. In place of A I am writing plus first occurrence, that is E plus E, you are going to get the production. In place of A, if you are writing minus, then you are going to get it as E minus E. In place of A, if you are writing star, you are going to get it as E star E. In place of A, if you are writing division, you are going to get it as E by E and power operator and minus or ID. One more rule for the operator grammar, it should not contain any epsilon productions. By satisfying these rules, after converting the general grammar to the operator grammar, then we can apply that particular grammar to the operator precedence parser. And operator precedence parser, we need to construct the operator precedence parser by using some rules, because when we are evaluating any expression, Okay, we are evaluating the expression means we may have different type of operator, different precedence of operators will be there. According to that, we need to evaluate the expression. First one is the rule 1, that is called as if precedence of B. For example, if you are defining the precedence on two operators called as A comma B, precedence of B is higher than the precedence of A, then we can give it as A is having lesser precedence over B. We need to insert the symbol as less than followed by a dot. Then if B is having same precedence like A, then we need to write the precedence as A is equal to B. If B is having lower precedence than A, then we can define it as A greater than B, where A and B are two different operands. Or sometimes same operands also, nothing but if we are having equal precedence operators, we need to go for associativity rules. In those, one depends upon the associativity, left operator and right operator, which is having higher precedence. Based on that, we need to insert either less than symbol or greater than symbol. Then second rule is an identifier is given a higher precedence compared to any other operator, because when we want to evaluate an expression, we may have some operands as well as operators. You need to evaluate the operators means first we need to know what are the operands. Here the operand is called as identifier. First we need to know the information about the operands. That's why identifier is having higher precedence than any other operator symbol by default. And dollar, it is nothing but to indicate the right end of your input. Nothing but whenever you have finished your input, that will be indicated with the help of dollar. So dollar we are going to see at the end of your input. That's why it is having very low precedence compared to all the other operators and identifiers. And third rule is if we have two operators with the same precedence that I have discussed in the first point, if we have the operators with the same precedence, then we need to go for associativity rules. These three rules will be used to give operator table. What are the operator relation? Precedence table we need to define for the given grammar for any one input string. Okay, we need to take the operators and operands and we need to define the precedence relation in between one operator and another operator. To define those relation, we need to consider these 3 points. And whenever you are having some grammar like E tends to EAE or ID and our operator symbols are either plus or star, then we need to construct an operator precedence parser by using our shift reduce parser. Okay, by default we are taking the stack as dollar. We don't have any symbols inside the stack and your input is indicated by ID plus ID star followed by dollar to indicate the end of your input. And we need to define the action depends upon the relation. If the relation top of the stack with the current input symbol, if the relation is less than, that is indicated by less than symbol followed by dot. If we are having the precedence relation as less than, then we need to perform a push action. Otherwise, if the current input symbol and the top of the stack, when we compare these two symbols, if the relation is greater than, then we need to perform reduce action. In this way, we need to repeat those actions and we need to see at the end of acceptance of input if it is a valid input. And first we are taking dollar and the given input, compare dollar and ID. When we are comparing dollar and ID, dollar is having always lesser precedence compared to all the other operators. Then we need to perform push operation. Then current input symbol will be pushed onto the stack. Next, ID and plus. Current input symbol is plus and top of the stack is ID. When we compare this, consider stack symbol as A and current input as B. Whatever the precedence relations that we have discussed previously, 3 steps, based on that we need to find out the relation in between. Stack symbol is nothing but A and current input symbol is nothing but B. A is ID and input symbol is plus. Here A is greater than B, nothing but ID is having higher precedence than plus. Then we need to insert the relation as greater than. When we have the relation as greater than, we can reduce the top of the stack. As reduction is performed here. Next, current input symbol is that we need to, already reduction is performed means you are not supposed to consider this symbol. Top of the stack is dollar with plus. Dollar with plus is nothing but dollar is having lesser precedence, then we need to perform push operation, then plus will be pushed onto the stack. Plus and id. Okay, plus is having lesser precedence compared to id, then what you have to do, just this lesser precedence means push, id will be pushed. Id and star. Next, id and star, where id is having higher precedence compared to star, then we need to perform reduce, that is e tends to id, and top of the stack is e. Then previous operator is plus and present operator is star. Then plus is having lesser precedence than star, then automatically that current input symbol will be pushed onto the stack. Star and id, then star is having lesser precedence, then id will be pushed onto the stack. Next, id and dollar, id is having higher precedence, then it will be reduced. Then you are going to get the production as e plus e star e. Then here the top of the stack is, next input symbol is dollar, dollar is having lesser precedence than the current input symbol, then what we have to do, we need to perform a reduce action. Then e plus e will be reduced to e. Once again same procedure, plus is having higher precedence than dollar, then we need to perform reduce, nothing but greater precedence, reduce, e plus e will be reduced to e. Then whenever we observe the top of the stack as e and current input is completed, input buffer is empty, then we need to give the action as accept. That is the implementation of the operator grammar with the help of operator precedence parser, nothing but the parsing will be done by shift reduce parser. And whenever we are converting precedence relation table to the function table, relation table is by default what are the relation between one operator to other operator. When you are converting this relation table into the function table, first we need to give precedence relation table as input. Then for every terminal, what we have to do is we need to create two symbols called as FA and GA. One indicates the row and other indicates the column. And divide the symbols into two groups by using equal to relation. Okay. For example, A is equal to operator A is having equal precedence than B. Then create FA and GB combined into different groups. Next, we need to repeat this process for all the operators. For example, we are having A is having greater than, A is having higher precedence compared to B. Then add, we need to write or we need to draw a edge between the two groups called as F and G. F is indicating the operator A and G is indicating the operator B. Depending upon this relation, we need to draw the edge in between these two groups. Okay, FA to GB because FA is having higher precedence than GB. Otherwise, if FA is having, A operator is having lesser precedence than B, then we need to draw an arrow from GB to FA. Okay, then by using this one, we need to construct a diagram for each and every terminal symbol that you are taking inside the grammar. Whatever the operator relation table is there, for every operator relation table symbol, we need to construct the diagram. And after constructing the diagram, we need to verify is there any cycle inside the diagram. If there is any cycle inside the diagram, then we need to stop the procedure and we need to declare that we are not able to construct the operator precedence function table. Then if there are no cycles, if it is not following the above case, then what we have to do, if it is acyclic, we need to calculate the length of longest path from FA to any terminal to the dollar symbol. By using that, we need to convert the table into a function table like this. This will be converted into the function table. This is already, we know that it is the operator relation table. Okay, in this we are not defining the precedence ID on ID because on two identifiers we are not able to define the precedence. Dollar and dollar also we are not able to define the precedence. And ID is having higher precedence than plus, than star, and dollar, that For that purpose, we are inputting the symbol or inputting the operation inside the table as greater than symbol. When we need to write the greater than symbol, dot followed by greater than, you have to write. This is the symbol to indicate the relation in between one operator to other operator. Next, plus and ID. Plus is having lesser precedence. Plus on plus. When we observe this particular cell, plus on plus, what we have to do in plus on plus, left two operators are having equal precedence. When these two are having equal precedence, what we have to do, left, we need to go for associativity rules. Leftmost plus is having greater precedence than rightmost, then first place is greater than second place. Next, plus on star. Plus is having lesser precedence than star. Plus is having higher precedence than dollar. Next, star on ID. Star is having lesser. Star on plus, star is having greater. Star on star, star is having greater. Star on dollar, star is having greater. Okay. Next, dollar is having lower precedence compared to any other operator. Dollar on dollar, we are not able to define the precedence. Depending upon this particular relation table, we need to construct a diagram. This will be considered as F group and this will be considered as G group by considering this. This one is F and this one is G. And for every operator symbol, what we have to do, we need to go for a vertex. And for this, whatever the operator relations are there in between one group to other group, we need to draw the edge from one to other. And whenever after a graph is constructed, we need to verify is it is a cycle graph or acyclic graph. If it is a cycle graph, it is not possible to construct the operator precedence parser. If it is acyclic, then we need to calculate the length of longest path from the given node. For example, for F plus, from that node to any $1, what is the length of longest path? That value we need to enter inside the function table like this. We need to construct the diagram of relation. For the precedence relation table, we need to divide into two groups, FID and GID. The FID, we are having G star, F plus and G dollar. For every terminal symbol, for every entry inside the table, nothing but for row and column, we need to create the groups. For every group, we are having the different symbol called as ID and plus, star and dollar. ID plus, star and dollar. And after drawing the vertices, we need to connect the vertices with different edges depending upon the precedence relation. Whatever the relation that we have defined in the previous table, by using this previous table, what we have to do, just we need to draw the edges in between the vertices. Just FID, ID is having higher precedence than plus. That's why we are drawing from ID to G plus. Next, we need to repeat the process for each and every vertex. How we need to connect, that will be given with the edges. Okay. After that, we need to verify can we find any cycle in between this. When we observe this one, we don't have any cycle in this. Nothing but it is a acyclic graph. Once you find that it is an acyclic graph, then we need to convert this graph into a table that is called as function table. Already we have defined a relation table to define the precedences of the operators. Then why we need to go for the function table? To nothing but to reduce the number of entries, to reduce the length of the table, we need to go for the function table. Here also we are defining the precedence relation only. What is the precedence of ID over star, ID over plus, ID over dollar? Okay, like plus over dollar, plus over ID, plus over plus, and plus over star and plus over dollar. And how we are getting these entries? These entries are nothing but just what is the length of longest path from FID to any $1. First, we need to find out the path from FID to dollar. When you are finding the path, first one is FID to G plus is there, G plus to F dollar is there. Here the length is only 2. When you line these numbers, just the length is 2. But we have some other paths also where we can reach either G dollar or F dollar. I am finding one more path, that is direct path is there, that is where the length is only 1. Next path FID to G star. Here the length is 1. G star to F star, length is 2. F plus to G dollar, the length is 3. And one more path is there, FID to G star 1, G star to F star 2, and the length is 2 only. And we need to find all the possible paths. One more path is also possible, FID to G star, G star to F plus to G plus to F dollar. This is 1, 2, 3 and 4. And all these constructed paths which is having highest length, this path is having highest length. Then we need to consider this path and we need to enter that number for this one. That is the length of the longest path is 4, that we need to enter here. Length of the longest path is 4. Okay, next we need to repeat the procedure for the remaining vertices also. Next, what is the next vertex? F plus. Then we need to find the length from F plus to any dollar. Direct dollar only 1. And from F plus to G plus to G dollar, and the length is 2. We are having only 2 possible lengths, and in this one length of maximum length path is having the length as 2, that we need to enter here. Repeat the process for F star, F dollar, G star, G dollar. Every symbol we need to repeat it and we will get the entries like this. By these entries we can know that, for example, we are taking FID and plus. Okay, FID and plus. From one group we need to take one operator and other group we need to take other operator. We need to compare the values. Whatever the comparison that you get, that will give the comparison in between the operators also. ID and plus. ID value is 4 and plus value is 1. Automatically ID is having higher precedence. Next, ID and plus. Here also ID and star, ID and dollar. Dollar and dollar we are not defining any precedence. Next, plus and plus. First plus and second plus. Left plus is having higher precedence compared to right plus, that is given as 2 and 1. Next, like this. By seeing this table also, we can tell that what is the precedence in between the operator. Okay, when we will see this particular table, we are having less number of rows compared to the previous table, and the table length is reduced. That's why we need to convert the relation table into the function table. Okay, this is about today's class. In next class, we will discuss about LR parser. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.